All right, welcome to week 7 of our video series in our geometry class. This week, we are doing another Heart of Algebra lesson. We are working on the learning targets. I can graph a linear inequality, and I can graph a system of linear inequalities. So everything's going to boil back down to that idea of, can we graph something that is in slope-intercept form? So y equals mx plus b is, again, that idea of slope-intercept form. So we are going back to that problem of, can we graph this? So we need to make sure we can identify our slope. We need to make sure we can identify our y-intercept. We need to make sure that our slope goes in the correct direction, but that's what we're going to work on today. All right, so graphing a linear inequality. It is not very much different than graphing a line. And graphing the line is the first part of this. So step 1 is to actually graph the boundary line. When we are doing that, we are either going to draw a solid or a dotted line. So these two things go together. It is a solid line if it is greater than or equal to, or less than or equal to. It is a dotted line if it's strictly greater than or strictly less than. After we graph the boundary line, and we're going to do a couple of examples, so please don't panic. We are going to choose a point that is not on the line. We are going to test that point, and then we are going to shade the inequality. So this aspect that is in pink is kind of the new idea. The stuff that was in yellow, that's the starting point. That's where we were with graphing linear equations. So now we're going to move on and we're going to graph linear inequalities. So let's look at an example. Now again, could you have paused the notes and written everything down if you needed to? Absolutely. All right, so y equals y is less than negative 2x plus 3. So we're going to start, and we're going to start the way we've been doing. We're going to identify our slope. We're going to identify our y-intercept. If you are following along, you're going to identify your y-intercept as the number 3. Your slope is negative 2, and yes, you're right, you're going to put that over 1. Now, we've been practicing. Negative 2 does mean down 2. It does mean right 1. So we're going to actually do that. The opposite that means exactly the same is up 2 and left 1. But we're going to start at our starting point. So again, there's our starting point at 3 on the y-axis, 1, 2, 3. Now I'm just going to skip count down 2 and right 1. And I'm going to go down 2 and right 1. And remember, I like lots of them. It makes it easier to graph my line. So the dots piece, up 2 and left 1, same deal. Those points still fall in the same line. Now the question is this a solid line or is this a dotted line? So if we go back up to our notes, we see strictly greater than or less than is going to be a dotted line. And that's because the boundary line doesn't actually count in our equation. So there's our boundary line. It is dotted. Now comes the second part of this. This is where we need to choose a point and test it. And we're going to choose a point not on the line. Mathematically, I like the easiest points I can find. So if 0, 0 works, I'm going to test it. But again, the big thing is that point that we're going to test is not allowed to be on the line. Okay? So it needs to be either above it or below it, but not on the line. So I'm going to test the point 0, 0. So that means x is 0 and y is 0. So I'm going to substitute y, 0, less than negative 2 times 0 plus 3. Well, 0 is less than, what is this? That's right, that's 0. 0 plus 3 is 0, or 0 plus 3 is 3. Now, the question I ask, is this true or is this false? Is 0 less than 3? Yeah, exactly. It is true, 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 true. So, since 0 is less than 3, that means that any point on this side of the line is going to produce a true statement. How do I show all of them? I do what is called shading. Now, I have a highlighter, so I'm going to use that. But, you know, I don't feel like drawing a lot of it, so, or shading the whole thing. So I will show my shading by drawing some lines to the left of the boundary line. That means everything that's highlighted, every point that's highlighted is a solution to the inequality. Because inequalities mean there are a lot of solutions. So if I asked you if x is greater than 3, can you give me at least one example of a number that's greater than 3? Could you give me 2 examples? Could you give me 3 examples? Could you give me 100 examples? Absolutely. So this is the same deal, but this is now dealing with linear equations as opposed to just a single variable. All right, let's proceed to the next one. So again, boundary point. What is our boundary? Our b value is -2. Our slope, yes, you're right, is 3/4. So that means I'm going to go up 3 and right 4. Or I'm going to go down 3 and left 4. So I'm going to plot my starting value at -2. Up my 3 units over my 4 units. Up my 3 units over my 4 units. Down 3 units, left 4 units. Down 3 units, left 4 units. Yeah, that last one doesn't look right, does it? No, I needed to go one further. Now, the next thing I ask myself, is it a solid or dotted? So I take a look at my inequality. It has an equal to, so it is going to be a solid line. So I am going to extend my line. Yeah, close enough. Now, all I need to do is test a point. So I always like to test in a different color. What point would you like to test? Can we do 0, 0? Is 0, 0 on the line? Nope, it's not. So I'm going to use 0, 0 again. Remember, if it is 0, 0 is on the line, please choose a different point. All right, 0 greater than or equal to 3/4 times 0 minus 2. 3/4 times 0, yep, you nailed it, is 0. That's why I like 0, 0, or x value of at least is 0. 0 is greater than or equal to -2. Is that true or is that false? You're right, it's true. So that means I need to shade on the same side of the line as the 0, 0. So that is above the line. So just to iterate, true, shade on same side with point, false, shade on opposite side of line. So there we go. So I am assigning a delta math assignment that goes with this. So I'm going to actually log off. I am actually going to go into delta math. I'm going to show you what this looks like. This equation or inequality is an example. It's one that we just did. So we did y equals 2/5, or y is greater than or equal to 2/5 x plus 3. So I'm actually going to put my dot at +3. Just touch it. Now, down to right 5. Now that would work if it was negative. It's not down, it's up. So I'm going to go up to and right 5, and I'm going to put my next dot, and it automatically forms a line for me. Okay? Now, if I look at the inequality, I need to ask myself, is it greater than or equal to or less than or equal to? This one's greater than or equal to, so it does mean that it should be solid. If it was supposed to be the other one, notice if I change the line, it changes it to dotted, back to solid, dotted, solid. We want ours to be solid. So now I test the point and I substitute 0, 0 in. If I substitute 0, 0, I ask myself, is 0 greater than or equal to 3? Because the 2/5 times 0 cancels. So is 0 greater than 3? It is not. So that means I don't want to shade below the line, I want to shade above the line. So I'm going to click shade Now this one's shading below, but we already said that 0, 0 isn't true. So we need to shade on the other. So if we click shade again, now it shades it above. So then I'm going to go down, submit my answer, click yes, and I did get it correct. So greater than is shade up, or equal to means use the solid line. So that's exactly what we just talked about. Again, if I looked at another problem, I'm going to start this one at -3. I'm going to go down 1 and right 2. So there's that. But this one's not solid line. It should be a dotted line. 0, 0, 0 is less than -3. That is false. So I'm not going to shade above. I'm going to shade below. And let's check my work. Let's make sure I know how to do this. And yes, I got my big green check, and I can see that my answer does agree. Okay, so there's the delta math aspect of what we're actually doing. All right, on to solving graphing a linear inequality system. Process is going to be identical. We're going to graph the first line. We're going to graph the second one. And then the answer to our system is look for where the shading overlaps. That's it, not going to change. So let's do the first one in this pink color. M is 3/1. B is -7. So we're going to go up 3, right 1 from -7. Up 3, right 1. I'm going to do that a few more times. Solid line or dotted line? Equal to means solid line, so I'm going to go with my solid line. All right, now I have to do my shading. So I'm going to test 0 less than or equal to 3 times 0 minus 7. 0 less than or equal to -7. That is false. So I'm not going to shade on the side with 0, 0. I'm going to shade on the other side. Now again, I use these lines. It helps me see my shading. All right, second one. Let's do this one in green. The second one is M is 3/4. B is +2. So I'm going to go up 3, right 4, or I'm going to go down 3 and left 4. But I'm going to start this one at +2. Up 3, right 4. There's my point of intersection. That's kind of cool. 1, 2, 3, 4. I can also go down 3 and left 4. Down 3 and left. 1, 2, 3, 4. Solid or dotted? Yep. Less than or equal to does mean just dotted. I'm going to test that same point 0, 0 again. 0 less than 3/4 times 0 plus 2. What's 3/4 times 0? Yep. 0 less than 2. That is true. So that means I need to shade on the same side as my dot. So I'm going to shade below my line because it's less than. Now, the last step of this was to look for where the shading overlaps. So I can see the overlapping along this boundary, right? Along this boundary. And all of this is where it is overlapped. So where it's overlapped is a solution to the system of inequalities, because that means there's more than one solution. There's a whole gaggle of solutions. So if I were to actually pull out like the big guns, let's pick out this red. This point, 5, 0, is a solution. This point, 7, -5, is a solution. This point, 6, 7, 8, 8, 6 is a solution. All of those points are solutions to the inequality system. Okay? All right, last example. What kind of lines? Solid on both, you're right. And now we just need to graph them. So first one, m is 5 over 1. So up 5, right 1. Down 5, left 1. Sorry, my y-intercept is positive 4, so I'm going to start at 4. I'm going to go up 5 to 9, and over 1, down 5, left 1, down 5, left 1. Yeah, and then I run out of space. Close enough. We did say that they are going to be solid. That is correct. And that's really a crappy line. Let's try that again. No, jeez. Why can't I draw a straight line today? Close enough. All right, let's test our shading. I'm going to test that point 0, 0. 0 greater than or equal to 5 times 0 plus 4. Is 0 greater than or equal to 4? Nope, that's false. So I'm not going to shade on the same side of the pink line. I'm going to shade above the pink line or to the left. Okay, second equation. M is 1/2, so rise 1, right 2, down 1, left 2. Our y-intercept is -5. So positive line goes up. Negative line goes down. There's my point of intersection. I'm not looking for the point of intersection. I'm looking for the intersecting shading. This is going to be a solid line. And if I test 0, 0, 0 less than or equal to 1/2 of 0 minus 5, that's 0. 0 less than or equal to -5. You're right, that is false. So since it is false, I'm not going to shade above the line. I am going to shade below the line. There's my computer telling me something's going on. It doesn't really matter. So I'm going to look for the overlap. I found the overlap in the center, right down here. It's where the pink and the green meet. So I'm shading that like a darker gray, but that tiny little area is where they intersect. So I'm going to pick a point in there and I'm going to test to make sure it's true. We're going to go -5, -10. I can test that. -10 greater than or equal to 5 times -5 plus 4. So -10 greater than or equal to -25 plus 4. -10 is greater than or equal to -21. That checks out. Not 20, but 21. Test it in the second equation. -10 less than or equal to 1/2 of -5 minus 5. -10 less than or equal to -2.5 minus 5. That's -10 is less than or equal to -7.5. That is also true. So that means that point does meet the conditions. Okay. Last step, one more Delta Math break. I just want to show you what it looks like with a system. So go back into Delta Math. Get rid of that. We're going to graph the first equation. We're going to start at -6. My rise is 2. I'm going right 1, so that's my first line. It is solid. My second one starts at -1 and goes down 1 and right 2. Again, that's also solid. What I should have done is gone back to line 1, tested 0, 0. 0 is less than -6 is false. So I'm not shading with the 0, 0. I'm shading on the other side. Drop down, go to line 2. Test 0, 0. 0 is less than or equal to -1 is not true. So the shading is not above. The shading is below. So see where the shading overlaps. Let's identify a point in there, because that's what we're being asked to do, is state the coordinates of a point in the solution set. If I went to +3 and dropped down to 6, 3, 6. Submit our answer. Did I graph our line wrong? What did I have? Oh, 3, 6. 3, 6 is over 3 up 6. That doesn't fit in the solution. My stated solution is not in the solution set. Eek, I meant -6. Let's try one more. Let's make sure we can do these. All right. So -4 is my starting point. We're going up 1, right 1. That one should be dotted. 0 less than -4 is not true, so it's not above, it is below. Next line, starting at 5, touch, going down 1, right 1, or down 1, right 2. It is solid. 0 is bigger than 5 is false, so that means I'm going to shade above. So that little overlapping section, let's see if I can get this right this time. How about 10, 3? Over 10, up 3. 10, 3. Submit answer. Let's see if, hey, I figured it out. So we can see that our point 10, 2 works, our point 10, 3 would work, but we there have it. All right, so your assignment is to get 5 right in Delta Math for both graphing one linear inequality and graphing systems. Is this something that's probably skill-based? Most likely. This is probably concept, Cougar Path type question, but you will be needing to know how to do these. So again, hopefully you watch the video before attempting the Delta Math, otherwise it may not make sense. So, all right, have at it. Thank you guys for coming today, and talk to you later.